Welcome back to inverse trig functions. Now this right here is a really helpful graph to memorize. This graph is a visual representation of the domain restrictions for your inverse trig functions. So you'll notice cosine is from 0 to pi, inverse sine is from negative pi halves to pi halves, inverse tangents from negative pi halves to pi halves with our open circles. So this is a really good thing to memorize. Okay, so definitely try to memorize this. Now, one note right here. Remember that the answer to an inverse trig function must fall in the correct range, and there's only one answer. So let's follow that up with a couple examples here. We want sine of negative pi 6. By the way, word of warning, this is going back to your unit circle stuff. So negative pi 6 would be pi 6 in the negative direction, so clockwise. So about like that. This is negative pi 6. And the x and y values here, that just remembering from our unit circle, this is going to be root 3 over 2. This is going to be 1 over 2. Or that point, you can remember, root 3 over 2, 1 over 2. And my y value is negative. Now, I want to find sine of negative pi 6. Sine is my y value. So I find my y value here, negative 1/2. So what I want you to do is try B and C, sketch out your unit circle, and then find the y value at those places. Ready, set, go. Okay, you should have gotten negative 1/2 for both of them. 7 pi 6 would be right there on the unit circle, and 11 pi 6 is going to be at the same place at negative pi 6. But this is a problem, because if I look at D, I want arcsine of negative 1/2, which means what radian gives me a y value, because it's sine, of negative 1/2. That's what this means in words. Whenever you find arcsine of 1/2 or inverse sine of negative 1/2, same thing. It's saying what radian measures give me a y value of negative 1/2. But if I look here, I had 3 radian measures that all gave me the answer of negative 1/2. But there is only one right answer, and that's the answer that falls in your sine range, from negative pi halves to positive pi halves. Only one of those lies in that range, and that's that one. So that is our actual answer. We can do the same thing over here. So let's go to example 3. Arctan of 1. That is, what radian measure gives a tan answer of 1. So if we look at our unit circle, I want a tangent of 1, which, if you get a little practice with your unit circle, you know is going to be at the 1 over root 2 over 1 over root 2. Remember, tangent is y over x. So if I take the y value divided by the x value at this point, that's going to give me 1. That is at pi 4. But there's one other point on the unit circle that does that. And that's negative 1 over root 2 over negative 1 over root 2. That also gives you a tangent value of 1, and that value is at 5 pi 4. So both of these are radian measures that give a tan answer of 1. But remember, we have our restriction. Tangent is only between negative pi halves and pi halves. So that means the answer I really want is going to be pi 4. That's the one between that restriction. Okay, I want you to try B, C, and D doing it the same method. where you've got each of these. You're going to make a picture, find the value, find the radian measure that meets that. Actually, let's do one more example as a class, shall we? Yeah, let's do that. Let's do this one. What radian measure gives a cos or x value of -1? So I want a cos or an x value of -1. Well, that one actually only happens at one place, right there. And that's going to be at pi. And that is within our domain restriction from 0 to pi. So that's going to be our answer. Okay, I want you to try C and D now. If you get a little stuck on D, that's okay. That one's a little weird. And then I'll come back and talk about them both. Welcome back. This one you should have gotten -pi3. There are two places that give you a y value of -√3/2. That's at 4 pi3, or this is technically 5 pi3. But remember, sign is restricted to -pi12 to pi12. So I'm going to want to change that 5 pi3 to a -pi3, so it's in that restriction. D is interesting. What radian measure gives a sine or a y value of 2? Well, none of them. What's the biggest that the unit circle gets to in y values and in x values? The biggest the unit circle gets is 1. So it's never ever going to reach 2. Okay, that's it for this video. In the next video, we're going to continue to review our inverse trig function